Scientists have made a groundbreaking finding that solves the riddle of what exists within a black hole. Black holes have long been shrouded in mystery since even light cannot escape from them due to their intense gravitational attraction. But today, as a result of the diligent effort of a group of researchers, we have some solutions. Hello, and welcome to my channel. In this video, we'll be discussing what scientists find inside the black hole. But first, if you haven't, please subscribe to my channel and enable the notification bell so you can see more interesting videos like this. So sit back, relax, and let's dive into the world of black holes. Both scientists and the general public have long been fascinated with black holes. These enigmatic phenomena, which are the result of enormous stars collapsing, are so dense that even light may be captured by their gravitational force. As a result, scientists must rely on indirect observations and theoretical models to understand their features, because they are hard to detect directly. Despite these obstacles, new technological developments and astronomical observations have enabled researchers to make substantial strides in their knowledge of black holes. The supermassive black hole that sits at the heart of our own Milky Way galaxy has now been given a first-ever photograph by astronomers. This study gives clear proof that the object is a black hole and sheds light on how these enormous objects, which are believed to be present at the center of most galaxies, function. For instance, a group of researchers from the Event Horizon Telescope (EHT) collaboration made news in April 2019 with the first-ever photograph of a black hole, which recorded the shadow the black hole's event horizon casts. The team, coordinated by Dr. Peter Doleman of the Harvard-Smithsonian Center for Astrophysics, observed the galaxy M87's black hole using the Event Horizon Telescope (EHT), an international network of telescopes. With a mass 6.5 billion times that of the Sun, this black hole is one of the biggest ones yet discovered. The EHT creates a virtual telescope the size of the Earth by combining the power of 8 radio telescopes spread out over the globe. The team was able to take a picture of the event horizon of the black hole in the heart of M87, which is the boundary beyond which nothing can escape the gravity of the black hole. The Astrophysical Journal Letters is publishing the findings of the EHT crew, a unique version today. The black hole looks to us to be around the same size in the sky as a donut on the moon, since it is 27,000 light-years away from Earth. The researchers developed the potent AHT, which connected 8 already existing radio observatories throughout the world to create a single Earth-sized virtual telescope. 1. To picture it. Similar to utilizing a long exposure on a camera, the EHT monitored Skura asterisk throughout several nights while gathering data for several hours at a time. The discovery comes after the EHT collaboration published the first photograph of the black hole, known as M87 asterisk, at the heart of the farther-off Messier 87 galaxy in 2019. Although our galaxy's black hole is 1,000 times smaller and less massive than M87 asterisk 2, the two black holes appear very similar. Sarah Markov, co-chair of the EHT Science Council and a professor of theoretical astrophysics at the University of Amsterdam in the Netherlands, says that although we have two very different types of galaxies and two very different black hole masses, they appear remarkably similar when they are near the edge of the black. This demonstrates that general relativity regulates these things up close, and any deviations we observe at a distance must be the result of variations in the surrounding matter. While Skura asterisk is substantially closer to us than M87 asterisk, this accomplishment was far more challenging. The gas around the black holes flows at the same speed, almost as fast as light, around both Skura asterisk and M87 asterisk. According to EHT scientist Chai Kwan, C.K. Chan of the Stewart Observatory, Department of Astronomy, and the Data Science Institute of the University of Arizona, U.S. Yet, although gas orbits the bigger M87 asterisk in days to weeks, it orbits the much smaller Skura asterisk in a matter of minutes. This indicates that the brightness and pattern of the gas surrounding Skura asterisk were fast changing, while the EHT collaboration observed it. It would be similar to trying to get a clear image of a dog that is frantically chasing its tail. The scientists had to create complex new instruments that took the passage of gas around Skura asterisk into consideration. Skura asterisk did not have the same photos as M87 asterisk, which was a target that was simpler to see and was more stable. The researchers ultimately revealed the behemoth hiding at the center of our galaxy by averaging the several photos they had collected to create the image of the Cigar A** black hole. The EHT collaboration, which consists of more than 300 researchers from 80 institutions worldwide, was instrumental in making the endeavor feasible. The team labored assiduously for 5 years, using supercomputers to combine and analyze their data while building an unprecedented library of simulated black holes to compare with the observations. This was done in addition to developing sophisticated tools to overcome the difficulties of imaging Cigar A**. The ability to compare and contrast two black holes of quite different diameters has scientists very enthusiastic about the arrival of photographs of the two of them. Scientists have also started to put hypotheses and predictions about how gas behaves around supermassive black holes to the test using the new data. While this mechanism is still not completely understood, it is believed to be crucial in determining how galaxies originate and develop. A hologram of a black hole could exist. The entire cosmos may even be a hologram. At least, that's one of the concepts underlying a new study that was printed in the PRX Quantum magazine. The research takes a closer look at what goes on within black holes. Also, it is an effort to comprehend the concept of holographic duality. Mathematical speculation, referred to as holographic duality, seeks to hyperlink theories of de Broglie and their interactions with the principle of gravity. Even though it sounds a little strange, it's a fascinating idea. Holographic duality essentially asserts that the theories of gravity and particles are interchangeable, at least in terms of math. Because of this, what occurs mathematically in the theory of gravity also occurs mathematically in the theory of particles. Each of these ideas primarily describes separate aspects. Yet particle theory only has 2 dimensions, but gravity explains 3. By exploring this theory, the researchers sought to get insight into what happens within black holes. So what is within the black hole itself, past the event horizon? Astrophysicists have debated this issue for a very long time, but it has escaped direct observation up until now. Researchers from the University of California, Berkeley, and the Max Planck Institute for Gravitational Physics in Germany may have found the solution in recent research that was published in the journal Physical Review Letters. The team was able to replicate the behavior of matter as it falls into a black hole using a novel theoretical model, providing insight into the singularity of a black hole, which is the point of infinite density and zero volume at the heart of a black hole. The new model, which builds on the loop quantum gravity mathematical framework, describes the physics within a black hole more thoroughly than earlier versions. The team's calculations predict that stuff falling into a black hole will experience intense compression as it gets closer to the singularity and finally reaches the Planck density, which is the condition of maximum density. At this point, the fundamental principles of physics cease to apply, and the singularity devolves into a world of quantum chaos. The team's simulations, however, indicate that the singularity is more like a fuzzy ball of spacetime that is spread out over a tiny but finite region rather than an infinitely dense point, as was previously believed. This notion of a fuzzy singularity is not wholly original. It has been advanced in various ways by several earlier research. The new model, however, offers a more solid and rigorous mathematical framework for comprehending the idea. The new model may have consequences beyond the study of black holes, according to Yasunori Nomura, a physicist at UC Berkeley and the paper's primary author. He stated in his statement that the idea of fuzzy singularity could be a universal property of quantum gravity. If true, it would aid in efforts to reconcile general relativity and quantum mechanics, 2 concepts central to contemporary physics, but have resisted reconciliation for many years. The study's conclusions have already sparked a great deal of curiosity among physicists, who view the new model as a development in our comprehension of one of the universe's most puzzling phenomena. Theoretical physicist and Nobel laureate Frank Wilczek stated in his statement, "This is an intriguing conclusion that opens up a new way of thinking about the inside of black holes. It shows that black holes are structures with complex interior dynamics, rather than merely emptiness." The researchers were able to explain what the gravity inside a black hole looks like using the models they created. Yet the black hole seems 2-dimensional from the outside. Since they fail to recognize it as a 3D object, this gives it a holographic appearance. This is because the 3 dimensions are not compatible with the particle theory. The study does, of course, have its limits. The simulations of the team are predicated on a variety of hypotheses, and there are still a lot of open concerns regarding the behavior of stuff within a black hole. It is also unknown how the results would apply to spinning black holes, as the new model only relates to non-rotating black holes. With that being stated, we have concluded today's video. Thank you for sticking with us through it, and I hope you liked the journey. If you enjoyed this video, don't forget to hit the subscription button and the notification bell to get notified when new videos are uploaded from our channel. What do you think about the black holes? Let us know in the comment box. Thank you. See you in the next video.